Okay, as you can see, some of these you've probably never, gentlemen, you've probably never seen some of these. Third time. Some of this may be very new for some of you, seeing it in this written form. The first one should be pretty easy. This says the square root of 36 gives you what? 6. Okay, anyone, can you explain to me how to get this answer? The square root of 17 squared. What do I get for that? Austin? Why is that? Yeah, the square root and square are opposites. So when you have a square root and then you have a squared, they cancel out, so you're just left with 17. That's it. This one. What do I do here for this one? 49x squared, the square root of 49x squared. Nick? Okay, I like your square root of 49, which is 7. And when I have a square root and a squared, that cancels out, so what am I left with? Just x. How about this one here? The square root of 3x minus 5 all squared. What happens there? Again, the square and the square root cancel out, so you're just left with 3x minus 5. Anyone have any questions with that? If you can remember squared and square root, they cancel out. It'll make your life a little bit easier. And we're going to be doing a lot of this today. Our learning goal, again, it's going to be another trick that you can use just like on Friday. I showed you the trick on how to factor perfect trinomials. Okay, so here is the big clue that you're going to want to use this trick. And this is called a difference of squares. This method only applies when there are two terms. So as soon as you see two terms, and the big thing here, what operation does difference mean? Subtract. So difference of squares means that there should be a subtraction sign. And the squares, if I look here, 1 is a perfect square number. 25 is that perfect square number. So the difference of squares. Nick, everything all right? Okay. So it says here, the question has two terms. So right away, as soon as you have two terms, the second qualification, both terms are perfect squares, and the binomials have a subtraction sign. Now, it becomes very easy once you recognize this. Your steps when you are given two terms with a minus sign and both are perfect squares, you take the square root of the first term, which we have done, and that's what we practiced last week. What is the square root of x squared, 1x squared? What's the square root of 1x squared? Austin? Just x. Again, the square root of 1 just gives you 1. And the squared and the square root cancel out, so I'm left with x. What does the square root of 25 give me? What is the square root of 25? Austin? 5. So both of those are perfect squared numbers. So I've done my first step, done my second step. Step 3, it says place a plus and minus sign in 1 in each bracket. So I'm going to create 2 brackets here. And all I have to do is take x, put it in both brackets. I have a plus sign, a minus sign, and put 5 in both brackets. That's it. Jenny? Say that again for me. It shouldn't have canceled out the variable. So which one are you talking about here? It just got rid of either the squared or the square root symbol. Okay, now again, to see this, if you wanted to check this with FOIL, again, what I do here, I multiply my first terms together. X times x gives me x squared. I multiply my outside terms together, gives me minus 5x. Multiply my inside terms together, plus 5x. Multiply the last terms in each binomial, I get minus 25. I can collect these like terms here, so I'm left with x squared, negative 5x plus 5x, that cancels out, so I'm left with just minus 25. Okay, so if you can remember this trick, it's pretty quick to actually do. Does anyone have any questions about it? Okay, I want you to try these 2 examples on your desk. Go. Exactly what we just did in that example, you can do to these 2 examples. Try it out. Okay, how do we do here? I have some perfect squares here, they're numbers. I can take the square root of this first term. What do I get? Zach? 5x. I take the square root of the last term. What do I get? Vanessa? 6y. So I have the square roots of each of them. Now I create 2 brackets. 5x goes in the first. I have a minus, a plus sign, 6y, 6y. How many of you got the first one correct? Okay, good. What about the next one? When I take the square root of the first term, what do I get? Jenny? When I take the square root of the last term? Good. Austin? What do you mean? No. FOIL, if you did FOIL, you should get this exact answer back. So that's just a check for your answer. Okay, what would I do for this next one here? What would be my final answer? Jenny? Good. Now, does it matter if you have the plus sign first or the subtract sign first? No. As long as one is positive and one is negative. Are we okay with that? Pardon? Yeah. That's the trick with difference of squares, because that middle term will cancel out, which is why we only have 2 terms instead of 3. Okay, so going back to your note. Now there should be some bells that ring off or go off in your head. If you look here, I have 2 terms. And I have a subtraction sign in between. So right away you should say, I want to use the difference of squares. But what do you notice about the numbers that are there? Nick? Yeah. I can't take the square root of 5. That gives me a decimal. It's not a perfect square. So that's why I have this big thing in blue. Remember to common factor out first. That's what you should always do. So I can common factor out a 5. And when I common factor out a 5, what will I be left with inside the bracket? Keep going, Jericho. Minus 4. Okay, now I have perfect squares inside that bracket. So I can take the square root of the first, which leaves me with just x. I can take the square root of the last, which leaves me with just 2. What do I have to do for my final answer here? What do I have to do here? What would be my final answer? There's one thing that some of you forgot to do when you were doing your quizzes. And that was, I have to carry down this 5. Okay, the 5 just doesn't disappear. Again, I still have two brackets, x plus 2, x minus 2. Okay, the next one here, again, I have two terms. There's a subtraction sign in the middle. I notice again that these are not perfect squares. So I see if I can common factor. What number can I common factor out of 2 and 50? 2. So I'll write here 2, bracket. I'm left with 1 minus 25a squared. What would be my final answer there? What would be my final answer? Nick McDonald, help me out. Very good. So again, what he did was he took the square root of 1, which gives you 1, the square root of 25a squared, which gives you 5a. Okay, in the next one here, what can I do here? This one's a bit special. Anyone notice something that's a little bit off here? Austin? Yeah, we can't do this if we have odd numbered exponents. We can't do it. So what do you notice that I can do here about that cubed? A 1a, right? Okay, so I'm going to factor out, and then I can also factor out a 5. So I have 5a as I can factor out. So I'm left with b squared minus 9a squared. Okay, if you have odd numbered exponents, this doesn't work. So that means that's either a sign that you would write you cannot, not possible, because it's not possible to factor. But here we can factor, we can common factor out. Now, what would I be left with for my final answer? I can take the square root of my first term, which leaves me with just b. The square root of my second term, which leaves me 3a. So my brackets here would be b plus 3a or b minus 3a. Anyone have any questions with that? Now this last example is an interesting one. I have a difference of squares here. Both numbers are perfect squares. I can take the square root of the first term, the square root of the last term. What do I get when I take the square root of this first term? Very good. How did you get that, Nick? Yeah. The square root is like saying, it's saying the exponent 1/2. So if I have this, that's the same as writing that. So this is actually like saying 4, the square root of x squared is like saying x 4 over 2, which is simple to just x squared, or as I think Zach or Nick said, you just divide by 2. That's why it has to be even. So I'm left with 9x squared plus 1, 9x squared minus 1. Anyone notice anything different here? Or anything special here? What do you mean square? Not. Pardon? Why? Yeah, look, I have another difference of squares right here. So this is like a double difference of squares. I take the square root of the first term, which gives me 3x. Take the square root of the last term, it gives me 1. And only because there's a minus sign does that qualify for that. If there's a plus sign here, that I can't do anything with that. So I carry this down.
Teachers, please excuse this interruption. This is our final call for collection day 1 of our popcorn fundraiser. We would encourage that you send down your envelopes at this time if they do have money in them. So if you could send down those final envelopes at this time. Thank you.
So just be careful when you have an exponent that's greater than 2, that you may have a double difference of squares like that. What do you mean? Difference of squares, it only qualifies when you have subtraction. So because I have a plus sign here, I cannot touch that one. I have to carry down the plus sign. Okay? Pardon? Yeah. Okay, now we get into some tricky ones. Again, I have, this is, you can consider this whole one here one term. This is one term. So I have a subtraction sign in between both. So I still take the square root of this. I take the square root of this. What do I get when I take the square root of that first term? 3a plus 1, because my square and square roots cancel out. And this one I get 9. You have to be careful with these ones. In my first bracket, I'll write 3a plus 1 plus 9. 3a plus 1 minus 9. Anyone notice what I can do inside these brackets here? I can't do that. What do you notice about the terms inside the brackets? I can simplify this one step further. 3a plus 10, 3a minus 8. So you want to simplify. You're collecting like terms with inside that bracket. Again, with this second one, consider this one term. This is the second term. They're both perfect square terms because it has this exponent too. So I can take the square root of this first one, square root of the second one. So I'm left with x plus 2, x plus 5. Now you have to be careful here when you do this. In my first bracket, I'll have x plus 2. I'm going to do my addition first, so then I add it with x plus 5. That one's pretty straightforward. You have to be careful with the subtraction one. Times x plus 2. I'm going to subtract it. I put the subtraction one in brackets because I'm subtracting that whole thing in there. So there's some algebra that I have to do to simplify that. What you could have done here is you could have also put another set of brackets right here. I didn't do that because when you're adding two binomials, it just gives you one anyway. You multiply one in. So I can simplify this first one to 2x plus 7. The next one I'm going to expand in x plus 2 minus x minus 5. I can simplify this next to 2x plus 7. My x's here would cancel out, so I'm left with just negative 3. I'm kind of skipping that step of grouping the like terms together. If you have to do that, that's okay with you. Now, how would I rewrite this? Negative 3 times 2x plus 7. Those are application type questions where you have to kind of simplify all the way through. Does anyone have any questions about that? Okay, the next one. I have 4 terms. What should you think of as soon as you have 4 terms? Nick? We do factor by grouping. I look at these first 2 terms. I look at these 2 second terms. So in my first term here, I can common factor out a 4x. So I'm left with x plus 3y. Now, this is a little bit different. I'm going to carry down that plus sign. This one here, if you look, you have a difference of squares. It's okay. This is I can still take the square root of this. I can still take the square root of that because that's a difference of squares. So I would have here plus 3y minus 2z, 3y plus 2z. Let's do it that way and see what we get. So you're saying reorganize this into 4x squared, and then you wanted it with plus 9y squared. Then your next two terms was plus 12xy minus 4z squared. Oh, put the 4 and 4 together? Okay, let's see. 4x squared minus 4z squared plus 12xy plus 9y squared. I have a difference of squares here. Actually, I can factor out a 4. Factor out a 4. So I'm left with x squared minus z squared. I can factor out here a 3y. So I'm left with 4x plus 3y. Then here I have 4 bracket x plus z, x minus z, plus 3y, 4x plus 3y. You're not going to get a question like this. Don't worry about that. That's I'm trying to think if I would have copied that down incorrectly. But I think here, I would have just stuck here. You notice that this was a difference of squares. You could factor those two terms, these two. We'll go with that. You don't have to worry about it. Okay, I'm going to give you a worksheet to practice this.